Hey everyone, welcome back to this YouTube series. I'm doing a very opinionated ASP.NET Core Architecture. I'm already regretting the title. Anyway, this is video number 7, Codifying Code. So in this session, what we're going to be talking about is essentially what we can do within C# to write code to make our code better in some way. So we're going to start that by talking about the C# Roslyn compiler and what features of the compiler make it capable or make it easy for us to go ahead and write our own analyzers, source code generators, that, you know, all of that fun stuff. If you're already very familiar with what the Roslyn compiler is able to do, you can go ahead and skip this beginning section because I'm really going to be starting with very much just an overview of that kind of stuff. So with that, let's talk about the Roslyn compiler. So when C# was originally created back in, I knew I should have looked up the years, 1999, and I think it was released in 2000, 2001. I forget the exact years, somewhere in that range. C# didn't exist, so as a result, the compiler was written in C++. That was the technology that Microsoft had at the time. Fast forward over a decade later, and Microsoft was getting to a point where they were saying, hey, every release of C#, we're adding these cool new features, but we're only doing big bang features. There are some other quality of life types of features that we want to go ahead and add, but it was difficult. It was hard to do in that, the way the code base was architected at the time just made that harder. And I'm going off of things I've read them saying. I don't know. I was not part of that. I'm just going off of memory. So if I get anything wrong, I'm sorry about that, but that's the gist. So eventually they decided, hey, let's go ahead and rewrite the compiler to C#, and we're going to call that one Roslyn, or at least that was the code name, and then the code name stuck around. So the idea is the compiler for the language is going to be written in that language. So the C# compiler is written in C#, VB.NET is written in VB.NET, and then F# still being a big part of the .NET community. That one actually, from my understanding, and again, this I could be wrong too, this is what I get for doing a lot less research ahead of time than I probably should have. The F# compiler is its own separate thing. It's not Roslyn, but it is written in F#, and just kind of following that model. I think actually F# did it before the other two, before C# and VB.NET. Anyway, compilers are now written in their language, at least in the .NET, or at least these three. I don't know about the others. But the big benefit was that, hey, with Roslyn as a compiler, Microsoft is able to take the learnings from the decade of writing C# and go ahead and, start fresh, make some things that were harder to work on or easier, all that stuff. But because it's written in C#, some things are also just easier to write features for, and as a result, we got an API. Everyone who uses the compiler, we got an API to start plugging in to things, to plug into times when the compiler is going to do certain things. So one of those cool plugin things that we got are making analyzers, right? So we get Roslyn analyzers, and these are things that can go ahead and check our code at compile time. So I think it was probably back in video 1 when I said, hey, we're going to go ahead and enable all of this code scanning stuff, right? All of these analyzers. So all of those are written as Roslyn analyzers. So some of them are built into .NET for us. We just have to go ahead and enable them in with a flag for the compiler, and that's done through the CS project. Or we can go ahead and reference a handful of other NuGet packages, and we bring those in. And we're doing both of those within our code. Actually, I can go back, and I'll double-click on the feedback app, so the one that we're working on, right? So this Sonar Analyzer, C#, these are all C# Roslyn analyzers. And if I scroll up a little bit, remember this enable net analyzers, right? That one built in. Those are all those are all C# Roslyn analyzers. So, you can see something built in, or we can just go ahead and reference them. And then also, if I just go over to the project and I look at NuGet packages, if I browse just the word, analyzer, and if I spell it correctly, you'll see there are a lot already written. Serialog analyzers, if you want, something to say, hey, are you using Serialog the way we want you to, stuff like that, right? There are a bunch of them in here, style cop, etc., etc. So, back here. So, that's analyzers, right? It's as you're compiling, this thing is going to go ahead and check your code, and then is it following whatever rule you want? And if not, then let's go ahead and throw a compiler warning, error, suggestion, etc. One of the other things that you can do with an analyzer, a Roslyn analyzer, is you can go ahead and actually have a code fix for it. So you can say, for example, hey, you should not use, what's a good example? Hey, you're setting a variable to some string and you're never using that variable. So a code fix, a sample of a code fix would just be deleting that line, right? Or, if it's the return value of a method, then maybe you set it to the underscore, right? That's the discard variable, right? Something like that, right? That would be a fix of an analyzer. So that's code scanning. That's one of the cool abilities that we get, or cool features that we get of using the Roslyn analyzer. Another cool thing we get are source generators. And the idea behind a source generator is at compile time, generate some new code that will be included in my binary and all that stuff. And so then that code also gets compiled in. So I want to be very clear. This is additive only. You are not able to modify any code. You are only adding new code files to the code. And that is a security reason. I can't imagine Microsoft ever changing that one, because if you could just start modifying someone's code, that can get a little crazy, right? We're not all paying attention to the NuGet packages we add, or the other one, the ones that we add, but they add, like 7 more, etc., right? So yeah, so just want to be clear about that one. But yes, with the source generator, you're going to go ahead and add code. So today's video, we're essentially going to be talking about adding, some packages like that to this project. And we're going to go ahead and use essentially ones that I've created, because I'm also going to go over the code for that. Just a reminder, like I say every other time, everything in these videos, these are all very opinionated. These are my opinions on the things that I prefer throwing into ASP.NET projects. Again, it's not for everyone, but if you have any questions, comments, concerns, etc., you have the YouTube comments right here for these videos, or their social media. You can find me on Blue Sky or LinkedIn. Just search Programmer Al. You'll probably find me. Okay, that stuff out of the way. Hey, we were talking about Roslyn analyzers, so let's go ahead and add a new analyzer to this project. So we're actually going to add an analyzer that I already have created. So I have a handful of packages on NuGet.org. If you just search Programmer Al, that name I use everywhere, you'll see a handful of things that I've created. But one of them specifically is this required auth analyzer. So I'm going to go ahead, copy that. I'm going to go over here to our NuGet packages. Oh, hey, apparently my watch just told me I hit my 250 steps for the hour, which is great. I didn't know I did that, but I always love it when that happens. All right, back to this. Anyway, so I actually have 2. They are different. For this project specifically, I'm going to use the first one. I'm not going to explain what the differences are. If you care, I tried to write the description in the readmes, which are embedded. So anyway, we have that, and let's go over here. So we've now added this. Let's see. Let me add a little bit more screen real estate. So we've added this NuGet package. So programmer.analyzers.required auth analyzer. So here's what the analyzer does. And you know what? I should probably explain a lot more. So let me comment it out. So we'll come back to that. Let's look at these endpoints. So we have within our project, a couple of endpoints that we've added, right? We've just the 2, right? One to get ratings and one to post a new rating, right? That's it. Very simple endpoints. So a thing that I personally, my opinion is that we should, on every single endpoint, add information to ourselves as developers, what rules exist for that endpoint, right? So as an example of that is I'm saying, hey, it is required that we have a request object. And then in that request object, we are specifying what is and isn't required in certain rules, right? We're saying the count is required. We have to have, when specifying how many ratings to get, we have to get at least 1 or a max of 50, right? Somewhere in that range, right? Those kinds of rules. Since it's also an endpoint, right? We might as well throw in some open API stuff, right? Summary, all that kind of stuff. I really like making sure that we have the types for something like OpenAPI, you know, our Swagger documents. So that's why I like putting in things like typed results, right? So that way the the generated Swagger, OpenAPI documentation specifies that this endpoint returns this data type, right? So I like having that kind of stuff. I like being very explicit about that. And so one of the things that we're not doing right now is we're not specifying what auth essentially is required, right? Authorization and authentication. And so there are a couple of different ways that we can do that within our, within an ASP.NET project. Here, let me bring this back. One thing we could do is we could, somewhere here in our startup, we can specify a global auth, and we can then say, hey, okay, listen, this is a public-facing API. There's not going to be any authorization required, so we can either do nothing, right? That's an option. We can specify, we can essentially hard code in and say all endpoints require no auth. And then, if in the future we go and add one, like some admin type of functionality, to say, okay, well, this one gets to, edit something, or, make it, let's change the visibility. Maybe someone was a little too mean about certain things, right? Or, some kind of bot spam, and we just want to remove it from the view. Maybe that's something an admin would go in and do. And that would require some form of authentication. You have to log in, and you have to have a certain authorized, role or scope or whatever we would want to use. And so what that means is then for that new endpoint, we have to go into it and we have to add, the authorized attribute and do all of that. And we have to hope that we don't forget to do that. Because what happens if we then go and add a second admin endpoint and we just forget to add that authorized attribute? And now, by default, because of the way we've set it up, this new admin endpoint is accessible to anyone, right? Because there's no authentication required. And that is a scenario that I do not like. I want to avoid that. And I don't want to have to remember certain rules like that. So a thing that I want to do is I want to go in and I want to say, hey, we have to go ahead and add the authorized attribute everywhere, right? So, right, authorize. Or in this case, specifically, it's allow anonymous, right? That I want to say that, hey, we should require that on every single endpoint, so that I, as a developer looking at this endpoint, I know what the rules are. I know that something talking to this anyone can go ahead and talk to this endpoint. So why don't we require that? And so that is exactly what this Roslyn Analyzer is doing. So if I go ahead and hit Control-Shift-B to build this, we should get some warnings. Hey, cool. Minimal API endpoint. All right. Minimal API endpoint, map post, requires an attribute specifying authentication or allow anonymous. Perfect. So I'll go ahead and do this. Allow anonymous. And did I forget to remove it over here? Oh, I did. All right. We just didn't. All right. There we go. Cool. Control-Shift-B. You know what? That might actually be a bug because they both have the same name. Similar? No, not really, because that's map-get. The other one's map post. Anyway, that is something I will look into. But we have a analyzer, and it's saying, hey, you have to have some kind of attribute here to specify what that is. And that's all we've done, right? That's what the Roslyn Analyzer does. So let's look at the code for that specific one. And so we're going to go to this one. So this code, it's all online. It's all on GitHub. And actually, do I have this up? Yeah. So if you find it on NuGet, we have the README right here is just copy pasted it. This is the same README that you get on GitHub, but if you want to, you can click on project site, and then that'll go over here, github.com program require-auth.analyzer. So that's all the same information there. But let's actually look at what we're doing within this analyzer. So we have a couple of projects over here and our tests. Always remember the tests. So we have two analyzers. So we're going to look specifically at minimal API. So there are slight different ways that you're going to want to check a controller versus a minimal API for our project, where we've already converted everything over to minimal APIs a couple of videos ago. So we're just going to look at this one. And so let's make this let's add a little bit more screen real estate. So as far as the API for working with Roslyn goes, you're working at the level of looking at the code. So it's very different from something like Reflection, which we're probably much more used to working with, right? Like when I first sat down to write this, I think I started and stopped like at least 10 times of, hey, let me start writing some code. Nah, this is difficult. I'll come back to it. And eventually I forced myself. But let's actually look at what's going on here. So we have our analyzer, and this is inheriting from diagnostic analyzer. All right, cool. We have a couple of constant values. We'll come back to this in a second, probably. And so we're going to go ahead and say, hey, we're going to go ahead and look at code, and we're going to register something. So this line right here, this is where we're registering with the compiler, and we're saying, hey, Roslyn, just whenever you see a invocation expression, just let me know. Just let me know, and I'll go ahead and run this analyze syntax node. By the way, this syntax kind, if I go to the definition, there are a lot of them. So it's one of the hard things if you're going to go ahead and start a Roslyn analyzer or anything else with a Roslyn API, getting that understanding of some of this, what you, just understanding what you don't know is difficult, right? There's a lot of stuff to figure out. Anyway, this invocation expression, if I go back to, where were we? Over here. If I go back to this code of this API, an invocation expression is basically this right here, right? Where we're it's not like a method exactly, right? But it's that invocation of something. Yeah. So that's the idea. We're checking this thing. Sorry, too many alt tabs. So when we actually want to check the code to see, hey, is this something that is the thing that we care to analyze, we have to have a couple of things to check. Okay, let's load some information. So is this a method? And is it a method for a minimal API endpoint? Because that's essentially what we're doing right here. We're only going to go ahead and add our rule for minimal APIs. And so there's a couple of things. It's a couple of hard-coded things in here because we're kind of making some assumptions. We want to make sure, hey, is this like a map, map group, anything like that kind of stuff, right? Because if I go back, if I'm going to go ahead and start mapping API endpoints, right, I can say group dot map something, and it's not always everything that we care about, but for the most part, we have to make sure we have to make sure that the thing we're checking is actually the thing we want to check, right? That's what this if statement is for. And then we let's see, is method inside route builder? Oh yeah, that's right. Then we have to check, hey, is this thing inside of this, right? Is that's what's going on? Parent class. Yeah, if the parent class is get ratings endpoint? No, that can't be right. Well, now I'm looking. Now I forget. This is what happens when I don't, like I said, don't do as many things. Let's see. Endpoint builder. Oh, yeah, that's right. I'm sorry, because it's not this thing. It's this thing. Is this group, route group builder, right? This thing is the thing that is invoking that expression. So again, it's difficult. Like, I mean, I wrote this and I've already forgotten so much of it. So anyway, we're doing this if check. Is this the code that we actually care about? If it is, then let's actually analyze the, oh no, that is a method. That method name needs to change. That's because I copy pasted. I started with the controller and then moved over to the minimal API endpoint. So this will change at some point, but anyway, this is still just for the minimal API. And then we have to do a bunch of stuff to just go ahead and check, right? Let's get the, let's get a bunch of information about what's actually being run here. Let's see, we'll load the attributes, and we're just going to find, is of the attributes that are here, are any of them the allow anonymous attribute or the some form of authorization attribute? And if it doesn't have it, then we're going to go ahead and say, hey, let's go ahead and create a diagnostic. With the diagnostic is the thing we tell Roslyn, like, hey, here's a warning, error, suggestion, etc., right? So that's what we're doing. And we're going to create it based off of the rule and the location. The location being, where in the code it is. And then the rule, if I scroll all the way up here, this is the rule that we're using. So we have our diagnostic ID, right? PAL 2000, title, message, etc., right? So you saw all that text, right? So if I go and get rid of this right here and hit build, this, you know, PAL 2000 minimal API endpoint, blah blah blah, requires that attribute. Cool. And that's it. That's the Roslyn analyzer. So if you're interested in writing a Roslyn analyzer to get started, go for it. There's a decent amount of documentation out there. It's not the best. There are some things. Unfortunately, it feels like, as far as documentation goes, there are a decent amount of examples, not a lot in the way of documentation for how things work. So that part can be a little bit difficult to go ahead and get started. But yeah, if you want to go ahead and write one, go for it. And so the reason that I'm going over this video or going over codifying your code as part of this set of videos, is because I think we should be doing more of this kind of stuff to improve the quality of our code, instead of just having to remember this stuff, right? Something like this, right, of remembering or forgetting this attribute, you know, that is something that a PR could help find, right? But that means that everyone has to know the rule. Everyone has to remember the rule. And we're humans. It's very easy to forget this kind of stuff. And I know I've forgotten it plenty of times. So without this analyzer, without some automated form of checking, it's possible that I would have left a very large security vulnerability in my application. So just something to think about, right? If you think you can automate some kind of check for some standard pattern that you want to do on your team, give it a shot. Just go for it. Let's see how well that works out. You know, you don't have to make it open source. You can just, you know, be something internal within your organization. You know, all that stuff. So cool. So that is codifying our code, making a Roslyn analyzer. All right, now let's move on to the other one that I was talking about. Whoops, here we go. So the next thing is the source generator. So a really cool feature built into Roslyn is the ability at compile time to generate source code. So here's an example of something that I keep going to too many projects. I'm gonna close the analyzer because I keep hitting Alt-Tab to the wrong place. Okay. Close all of these things, starting over fresh. Where are we? Here we go, services. So here's a thing that I dislike. I hate having an interface just for the fact that I want unit tests to exist, right? So in this case, this ratings service, and then separately, the ratings repository, right? If I go to the definition of ratings repository, same thing, right? This thing exists, so we can write unit tests for this thing, right? For the ratings service. Technically, as far as our code exists right now, we don't really need this interface because we don't write unit tests for the endpoint, because the endpoint is the only thing using this. Anyway, it doesn't matter. It's still the standard pattern, right, of what we do. So a thing that I want to do that I think would be better is, why don't we just at runtime or at compile time just generate the interface? Because if it only exists for that, right, if it should be a direct copy of the concrete class, then there's no point in us typing this thing out. Because the other problem is, hey, what happens if all of a sudden I decide to, you know, change, let's say I decide to add string, phone number, right? So all of a sudden someone wants to give us a phone number. Well, then now I have to remember, I have to remember to go over here and add it to the interface, which is not difficult. It's like 5 seconds. But part of that is, it actually is a little bit easier for me because I like putting the interfaces and the concrete classes into the same file. A lot of people don't do that, so then you have to go and look for it. And, those 10 seconds turn into 30 seconds, which isn't much, but it's an annoyance, right? Why don't we as developers decide to just improve our code by writing code, right? Let's do that. Let's do that fun thing, the thing we like. So what we should do is go ahead and use another package, another one that I have over here. There we go. So this is another NuGet package that I created just to practice source generators and get an understanding of them. So a program.sourcegenerators.public interface generator. And I'm going to copy that name over there. But here's the README file. The general idea is, let's go ahead and use an attribute to generate the interface. So if we go back, and if I hit Alt-Tab the correct amount of times, there we go. Go ahead and add it, and we'll use this first one. I'm very sorry about the .attributes one. That is a package I need to delete. There's a handful of packages that I have pushed up that should not be there anymore, and I could have sworn I delisted it, but apparently not. So that is on me. Anyway, so now we are going to go ahead. So now we have our package added. If I scroll down, hey, there we go. All right, programming.source_generators.public interface generator. Cool. And then we're saying, hey, everything's going to be private. And the reason we do that is if so something references this project, right? If it's like a shared project, a DLL or something, then those other things do not take a direct reference on this DLL, on this NuGet package, right? We don't want to force everyone else to have to use it. So what we're going to do now, and I'm actually going to go back to the README. So we have this attribute, generate interface attribute, and I'm just going to copy paste it. Generate interface, and I'm going to go ahead and add that using statement. Oh no, that's not what I want. I wanted. Okay, fine. So using this. Okay, cool. And let's get rid of the word attribute just because why not? And now we can go ahead and delete this interface right here. And if I hit Control-Shift-B, there we go, build succeeded on the bottom left. And so I can go to the definition of this file. I can hit F12 and we'll go to it, right? Hey, public interface, iRatings repository. Cool, we have everything. And if I decide all of a sudden that I want to go ahead and add the phone number, I just hit Control-Shift-B, and that's fine. Okay, that build failed for a second, but it fixed itself, right? I didn't have to build again. And now all of a sudden, hey, there we go. The code has been generated again. So this will save us tens of seconds, I think, over time, but it also cleans up our code a little bit, right? I think that this is a little bit clearer to ourselves as developers, because what we're saying is, hey, that interface is going to be exactly what the concrete class is. So whatever you see here, just assume it's in the interface, right? That is 90 some odd % of the time of what happens anyway. So why have that file exist in another place? I've heard the argument before that if you have the interface, you can put it all into a shared project and you can share that with others. I've never seen anyone do that, but it's a thing you can do, I guess, if you want to. Sure, have at it. Just let me know when you've done it. Yeah. So, so we can go ahead and add that, and I'm going to copy paste that one, and we're going to put that over here into our rating service. We're going to do the same thing. Delete this. Generate interface. Just going to copy paste that using statement again. I know why that using statement isn't showing up, why it's not great for that. But that is a separate conversation topic. Okay. So, let's see. We have a warning. Oh, whoops. Sorry. I forgot to get rid of that phone number. There we go. So, all right, everything should compile now. We're good? Yeah? All right, cool. I don't know why this using static is there. We'll just delete that while we're here. All right, cool. And I'll hit build again, Control-Shift-B. Cool. Build succeeded. All right. Yeah, and that's it. So let's actually look at the code for this source generator. Actually, you know what? One thing before we do that, there was something else I wanted to mention. If you want to see all of the generated code in your project, it's a little difficult, but if I go to my dependencies, and I go to packages, let me make this a little bit bigger, and then I find this one, source generator. Okay, that's not there. Whoops, I'm sorry. It's in analyzers. I was close. It's in the general region. So if I go to analyzers, and then I go to the generator, the source generator one, I can expand that, and we can see the 3 C# code files that are generated. So we'll go ahead and look at the 2 we've already seen, right? These are the 2 interfaces that we've created. So if you want to go ahead and see them somewhere, you can. The last one is the actual attribute, and so that is a thing to make writing the source generator a little bit easier. You make the attribute, you make the source generator generate your attribute for you, right? And so that is going to be, if I go back to it, that's this attribute file right here. And going back a little bit, that's why I couldn't just use the tool to go ahead and add that using statement, because it didn't really know that code existed, which is, right, it's in that middle state. Yeah, it's a little weird. But where is it? Yeah, so we have a couple of interfaces. There's also a bunch of rules in here, for things. As far as like, hey, I want to go ahead and exclude, a certain method or whatever from the interface, right? These are things that this code has to think about. And so Actually, if I go back, right, so we have, here we go. You can specify a bunch of properties, right? Interface name, interfaces that the interface inherits from. Is it disposable, async disposable, etc., right? So if you want to go ahead and set those are configurable options, essentially, that I had to think about when creating the source generator. But I just wanted to point out that, hey, this file, or this is where you would see those files. So let's actually look at the source code for that, just to get a general overview. So again, this is all on GitHub. You can go ahead and view that. And if I go back to NuGet, again, the programrl.sourcegenerators.public source generator, it has the project website. So that'll go ahead and take you directly to GitHub, where all of the code is stored. And let's actually look at this code. So looking over here, our public interface generator. If we go to, here we go, public interface source generator.cs. So this thing is going to go ahead and inherit from incremental generator. There's different kinds of generators. Incremental is just how it runs. The short answer is this is a performance thing. Just compiler runs when it sees something like your attribute, then it'll run your code instead of just run the whole thing and then decide at some point arbitrarily when to run it. So we're doing two things. The first is we're going to go ahead and add something to say, hey, we're gonna generate a source file, right? Remember that attribute file we were just looking at? Hey, we're gonna go ahead and generate this thing, just so you know, compiler. So we'll create that, and then that code is going to come from this helper method. And actually, I'll go to that definition. If you look at source generators, you're going to see a lot of this, a lot of just string manipulation, right? Just things that we want to go ahead and throw in, embedding a bunch of stuff. And so this one file just has a lot of methods to output code as a big old string, right? That is one of the downsides to writing a source generator, because you don't have IntelliSense for this kind of stuff, right? It's not perfect. It's not great. There are some options. I guess what I could have done is just put all of this code into a file and read the file. That probably would have been a little bit better. Then I have to ship the file to, what are the pros and cons with the package? The file still doesn't have source code, source complete and all that fun stuff. So anyway, so this is first off saying, hey, on the project using this, go ahead and create the attribute that they're going to use for us in our source generator to know when to write code. Then we're going to go ahead and have some code that'll go ahead and run and just search all of the code in the project to say, hey, and so this is actually just kind of a built into the Roslyn API thing. This is going to say, hey, for whenever you see the attribute with this name, right? And so this is the full name of that attribute, the one that we generated up here, this public interface generator attribute. Whenever you see this, run our code, but also it needs to follow this predicate. And if it's any code, sure, then this will just return true. But here we're going to say if that piece of code with that attribute is a class or a record, then we can go ahead and run it. Right? And so when we run it, we're going to run this code that we have, and I'll go to the definition. This is the class parser. Oh boy, yeah, right, there's a lot of stuff. So now we're going to go ahead and parse this, and so we're going to parse for all of those options that we care about, right? What's the interface name, the namespace, is it disposable, async disposable, etc., right? So we're just going to go ahead and look at all the attributes at the class/record level, and then all of the properties and methods and etc., all of that stuff. So a lot of parsing to figure that out, and we're just going to go ahead and store that. If I go to the definition, we're going to store that into some record called interface to generate info, right? This is just all of the stuff that we care about, so that later when we do generate our code, we're going to go ahead and use the information that we've stored here and from what we've parsed. So that's what this is doing. And then lastly, we're going to go ahead and register with Roslyn. We're going to say, hey, when we're ready to output code, when we're now that compiler, as you've gone and done your pass through all of the code, and we have found all the places where that attribute exists, let's go ahead and run this code when we're ready to go ahead and generate our interface. And so what we're going to do this is on for each interface that we've found that we've identified during that first pass. And then we're going to go ahead and generate all of our code. So this method is going to run for each one of those. And this is just going to be more of our string generation. So actually generating the code, if I go to that definition, if I hit F12, right? Remember this this record right here, the thing where we were saying we're going to store all of that information. So we're passing that in, and we have our string builder, and we're just going to go ahead and keep adding all of the string stuff, right? Namespace, we'll add curly brackets, opening, closing. If we want to go ahead and add the nullable to the project or not, all of that stuff, every property, every method, interface, event, even, right? All of that stuff. So we're generating the code, and then we're going to go ahead and output it, and we're telling the compiler, like, hey, Roslyn, yeah, here's the code. You can go ahead and output it to somewhere. In general, it's going to go ahead and keep it in memory. As a developer, if you want to actually write it out to a file, there is a flag. You can go ahead and do that. The downside to that flag is it's global to the project. So it's either all of your generated code goes out to a file or none of it does. So, but you get that choice, right? And so what we're doing here is saying, just compiler, include this in the stuff that you generate. Cool. And that's it. So that is how we get from this attribute to this generated code. And again, this is only generated at compile time, all that stuff. So if I hit Control-Shift-B, we see, hey, build has succeeded. We're able to run just like before. The only changes we've made this time around have been adding this this generate interface attribute to a few places, and then also we have, if I can find it again, and also we've forced ourselves to add some kind of authentication authorization attribute to each of our endpoints, and that is codifying our code, right? So I really think more developers should be thinking about ways to codify our code, because this is one of those things that forces us as developers to remember to do certain things. If you want to start with an analyzer, that would be great. That's always, a great start to something, just of, hey, I noticed this thing's here, just go ahead and do it. Do that thing that we both agree you should be doing, because you have added a reference to this project, to this NuGet package that has the analyzer in it. So obviously you want to do that thing. And yeah, the source generator, you don't have to, right? Like I just think that it's one of those things where if you invest the time in doing that, you will have a better code base from the perspective of how easy is it for a developer to read it and work with it and understand the assumptions around things like that, like those methods, etc. All right, cool. Looking around, I probably forgot one or two things to say, but I can't think of them, so I guess we'll go ahead and close it out now. All right, until next time, take care, everyone. Bye.